Hey, welcome back from module 20.2, which is the algebraic representations of dilations. So yesterday we were talking about dilations and the scale factors that they use and the relationship between that the pre-image and the image, and we were finding the scale factor by dividing the length of the image by the pre-image. Make sure that you review module 20.1 if that's new to you or if you have a little bit of confusion there. And of course, I'll be available on a Google Meet later today if you have questions on it as well. So remember when we did other transformations, when we were doing, the reflections and the rotations and everything. Do you remember how they had like an algebraic rule where you said the x and the y, and then you had an arrow and you did something to the x, either you added one or subtracted one for a transformation? Remember that? Okay. Well, the algebraic representations of a dilation is going to be a multiplied number. Okay, we kind of found that relationship yesterday with the scale factor when we were looking at the relationship between some of our images. I think I might even have one available here. Yeah, okay, so I found one. So if we had these images here, our scale factor was we took the original and we multiplied it times 2. This length, we multiplied it times 2, and we ended up with our image. And so that's essentially what we did, was we took the x value and the y value and we multiplied both of them by the same scale factor. And so the same thing is going to be happening here when we're doing the algebraic representation. So today might be a pretty easy day for you guys because we talked a lot about this already yesterday. So our algebraic representation of a dilation is essentially saying we are going to multiply the x value and the y value by the same coefficient, the same number, okay? And the reason why that's important is because that means it is proportional. It needs to be the same number that we're multiplying by in order for our final image to be proportional to the pre-image, okay? So if we just apply this rule, for sake of time, I ended up just writing down all of the coordinates for these already. You can see in our pre-image, this guy is 2, 2, and then 2, -1 is right here. So I just wrote that down really quick to save us some time. And we're going to apply this rule. So our xy is going to become 3x, 3y. And so if I multiply 3 times our x value, that becomes 6. And our y value becomes 6, right? You with me? Okay. And then if I do the same thing with the second one, 3 times 2 is 6, and 3 times -1 is -3. If I do the same thing with 1 and -1, I end up with 3, -3. 1, -2, I'm going to multiply each of them by 3, and I get 3, -6. -2 and -2, if I multiply both of those by 3, I get -6, -6. Careful of your positives and negatives. I just second guessed myself there. If I multiply -2, I get -6, and 1, I get 3. Multiply both of these by 3, I get -3 and 3. And for this one, I get -3 and 6. Okay, so those should be all of our new coordinates. And if I go ahead and plug them in, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, you can see that this is significantly larger. 6 and -3, so I know this is 6, 1, 2, 3, right here. I feel like I did something wrong there. 1, 2, 3, 4, 5, 6, -1, -2, -3. Okay, looks like I do have it. All right, and then 3, -3, 1, 2, 3, 1, 2, 3, and then 3, -6, 1, 2, 3, 4, 5, 6. And so let me start connecting these dots. You would, of course, use a ruler, right? And so you can see there, that's where I got messed up. I was thinking that it was a different part of it. Okay, and so I've got -6, -6. All right, so I'm 1, 2, 3, 4, 5, 6. -6 and -6 right here. And then -6, 3. 1, 2, 3, this guy here. and negative 3, 3. 1, 2, 3, and 3, and negative 3, 6. 1, 2, 3, 4, 5, 6. There we go. And so, as you can see, we have a similar shape. And of course, it is an enlargement. So, my friends, if you follow the rule for the algebraic representation of a dilation, in this case, since we multiplied by a number that is larger than 1, then we ended up with a dilation that was an enlargement. And of course, like I said, easy to follow, pretty easy day for you guys, hopefully. Let's go ahead and take it the other way though. And let's say here's our pre-image. I already mapped that out for us and everything. And this time we want our rule is to do a dilation with a scale factor of 1/2. And so if our scale factor is 1/2, do you think we're gonna have an enlargement or a reduction? Yeah, it's going to be a smaller figure this time. So I'm going to take all of our numbers that we have here and I'm going to multiply them times half. So I'm going to take my x value, multiply it times half, and I end up with 2. And 2 divided by, or multiplied by half or divided by 2 is 1. So my new values are 2, 1. For the next one, I end up with 0. 0 divided by half is 0. And 5 divided by half is 2.5. And then my negative 4, 2 is going to be negative 2, 1 as I continue to follow that. Okay, and then I've got negative 1, 1. I've got negative 1, negative 2. The next one is going to be 1, negative 2. And finally 1, 1. So I could do these as well, and I end up with 2, 1. Here we go. 0, 2.5, so 1, 2.5. And then I've got negative 2, 1. Negative 2, 1 right here. And then I've got negative 1, 1. I know this is like kind of annoying, isn't it? And then I've got negative 1, negative 2 right here. And then I've got 1, negative 2 right here. And then I've got 1, 1, which would be right here. And so you can kind of see my outline that I've got going here. And of course, I'm not drawing it perfect because I'm not using a straight edge, which you should. But you get the idea that we ended up with a smaller arrow on the inside. Okay, so notice that my rule was take both of the x and y values and multiply it by half. And if we looked at the corresponding angle or the corresponding lengths of the sides here and here, we will have a relationship that will be 1/2. So remember, we take the original, we take the result divided by the original, right? And so the result was the length of 1, 2, 3. So our result had a length of 3, and this had a result of, or the original was 1, 2, 3, 4, 5, 6, 6, which equals 1/2. So that shows that our scale factor was 1/2 to begin with. It shows that we were correct in our math because that scale factor for that corresponding side, if we took the result divided by the original, we ended up with 1/2, which was what we were given as our algebraic rule. Okay, so kind of connecting yesterday to today a little bit so that you guys are understanding what's happening in the connection. So let's go ahead and take a look at this one. This one says, graph the image of triangle ABC after a dilation with the origin as its center and the scale factor of 3. What are the vertices of the image? Okay, so let's think about this for a second. If I have a scale factor of 3, how could I write an algebraic rule for that? You got it. What we would do is we would have x, y would become 3x, 3y, right? Okay, so if we are going to take our image over here, and this is going to be 3x, 3y, and I'm simply going to take my a prime is going to be 3 times 1, which is 3, and 3 times 1, which is 3. My b prime is going to be 3 times 3, which is 9, and 3 times 1, which is 3, and my c prime, these both should be prime, is going to be 3 times 1, which is 3, and 3 times 3, which is 9. And so what I'm going to do is I'm going to graph these guys. 1, 2, 3, 1, 2, 3. Here is my A prime. Okay. And then I've got 9 across. So 1, 2, 3, 4, 5, 6, 7, 8, 9. Up 3. 1, 2, 3. Right here for my B prime. And my C prime is going to be 3 and 9. Okay. So 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. Right here. And my final shape. Notice the one thing that I want to point out to you is that it is not inside of the previous shape, and that's okay. I know that the last ones that we did were inside of like a shape like this. It was inside of each other. It doesn't always have to be that way. So don't feel like because it's removed and not around this other shape, don't feel like it has to be, because our origin was the center of that graph, and so we're okay with it. And so the question that they're asking us was, what are the vertices of the image? And right here we listed our vertices. So we are all set on that problem. Okay. Glad you put in all that work yesterday, because today seems like a breeze, right? All right, my friends. And the last one that we have for today says graph the image of XYZ, triangle XYZ, after a dilation with a scale factor of 1/3, and the origin is its center. Write an algebraic rule to describe the dilation. I like to start with the algebraic rule. So if we had XY, right? What happens to XY as our algebraic rule? What are we going to do that to make this dilation? Yeah, we're going to multiply both of them times 1/3. So it's going to be 1/3 X and 1/3 Y. So essentially what we're doing is dividing each of these numbers by 3, which is the same thing as multiplying by 1/3, right? So our image for our X prime is going to be 3 divided by 3, which is the same thing as multiplying by 1/3, right? Which is going to be 1, 1, because I did it for the X and the Y, so they'll be the same. For the Y prime, I got to take 9 divided by 3, which is 3, and the same thing for the Y value, 3. And for the Z, I've got 3 divided by 3, which is 1, and 9 divided by 3, which is 3. And so here are my new coordinates for my dilation. So let me go ahead and plug those in. I've got 1, 1, which is right here for my X prime. I think it's important for you to label it right away so that you know that this is coordinating to this point. These 2 points are coordinating points, okay? That way you don't get lost in it. And then I've got Y is 3, 3, 1, 2, 3, 1, 2, 3. Here we go, because now this is my Y prime and my original X. So that has 2 different points. So that's why it's important to label it right away. It is not corresponding to this. This X is not corresponding to, or this Y is different than the X, but it's at the same point. I hope that makes sense to you. This point right here is also corresponding to this point from the different triangles. Okay. 1, 3, 1, 2, 3 is up here. And so this is Z prime. And so my new triangle, if I would draw it straight, will be right here. And this is why I use straight edge, so you don't have to keep on making it thicker. And so that is my triangle XYZ prime, okay? So my friends, even though these have the same point, they are different corresponding. So as an X, it corresponds with X prime, and as a Y prime, it corresponds to the regular Y. I think I explained it better that time around. So my friends, believe it or not, that is it for today. It's pretty easy terms, I hope, for you, since you put in a lot of the work yesterday. Your work for today is going to be page 642, 643, and 644. Hot problems are optional. And if you have any questions, you can join me on my Google Meet at 1 o'clock. And if you don't, you don't have to. But please do me a favor and fill out the page where it says, what do you understand and what questions do you still have? That gives me a lot of information, and that's how I check in if you are doing your work. Okay? So I hope you have a great weekend, and we will talk soon. Take care, guys. Bye-bye.